Hi, welcome back to statistics class. This is our lesson, hypothesis testing. To guide you with our presentation today, here's an outline. We will define and discuss about hypothesis, the type of error, the level of significance, the critical region, and we will discuss the steps to hypothesis testing, which we'll be using for the rest of our lesson. And then we will review an example of hypothesis testing calculation in some parametric test. What is hypothesis? Hypothesis is a statement given by an individual. Usually, it is required to make decisions about populations based on some sample information. So such decisions are called statistical decisions. In attempting to reach decisions, it is often necessary to make assumptions about population involved. And such assumptions, which are not necessarily true, are called statistical hypotheses. So what is this hypothesis testing or significance testing? It is a method for testing a claim or hypothesis about a parameter in a population using data measured in a sample. So, in this method, we test some hypotheses by determining the likelihood that a sample statistics could have been selected if the hypothesis regarding the population parameter were true. So let's discuss it further. Again, hypothesis is a statement given by an individual. So it is a logical supposition or an educated guess based on observation. So in other words, it provides a tentative explanation for certain events, phenomena, or behaviors. It is a suggested solution for an unexplained occurrence that does not fit into current accepted scientific theory. So usually, this statement given by an individual, usually it is required to make decisions about populations based on sample information. So that is your hypothesis. Based on your sample, then you will have a decision regarding your populations. So such decisions are called statistical decisions. So in attempting to reach decisions, it is often necessary to make assumptions about population involved. And then such assumptions, which are not necessarily true because you have to test it first, these are called hypotheses or these are called statistical hypotheses. So for example, we have there is a claim that there is no significant difference on the math performance between education and engineering students. So that is your claim that there is no significant difference. So that is your hypothesis. So this is a statement given by an individual, and then after that you will take some information, gather some data in your sample, and then have your statistical decisions. So that is hypothesis testing. It is a statement given by an individual, and it is usually used or required to make decisions about populations based on a sample information. So that is hypothesis, that is your supposition, an educated guess based on your observation. And then what is this statistical hypothesis? So it is a conjecture about the value of the population parameter and distribution of the population. So if you have your hypothesis that is just a guess, an educated guess, then statistical hypothesis is a conjecture, assumption about the value of the population parameter and distribution of the population. And then what is this hypothesis testing or significance testing? It is a method for testing a claim, again, a method for testing a claim or hypothesis about a parameter in a population using data measured in a sample. So in this method, we test some hypothesis by determining the likelihood that a sample statistics could have been selected if the hypothesis regarding the population parameter were true. So you have your statistical hypothesis, and then you have to test it using some statistical analysis. Then you are doing this hypothesis testing. So in our previous example, we have to test if there is no significant difference on the math performance between the education students and engineering. So before we can conclude on that, we have to undergo hypothesis testing for us to have a valid statistical decisions or conclusions. So that is hypothesis testing. So for example, we have this decision rule. Reject HO if X bar or the mean is greater than 60. Otherwise, fail to reject HO or null hypothesis. So this is an example of statistical hypothesis testing. You need to have a basis for you to arrive a statistical decision. So, but we will discuss it further. So what is this null hypothesis or denoted by HO? Okay? So, null hypothesis, it expresses the idea of non-significance. So, it is a statement or conjecture which is being tested. So, we have the two hypotheses. We have the null hypothesis and then the alternative hypothesis. So, for null hypothesis, it expresses the idea of non-significance. So a hypothesis which is tested under the assumption that it is true is called null hypothesis, and usually, again, it is denoted by HO or H naught. So that's a hypothesis which is being tested for possible rejection under the assumption that it is true is known as the null hypothesis. So the statement opposes the perceived conclusion in a research. The null hypothesis or HO, stated as the null, is a statement about a population parameter, let's say the mean or the variance, such as the population mean that is assumed to be true. So the null hypothesis is a starting point. We will test whether the value stated in the null hypothesis is likely to be true. So for alternative hypothesis, which is usually denoted by HA or H1, it expresses the idea of significance. It is a statement that will be accepted in the event that the null hypothesis is rejected. If your null hypothesis is rejected, then you should accept this alternative hypothesis. It generally represents the hypothetical statements that the researcher wants to prove. An alternative hypothesis, denoted by HA or H1, is a statement that directly contradicts a null hypothesis. So, if the null hypothesis would state a non-significance, then your alternative hypothesis will contradict it. So, it will present a significant statement. So, by stating that the actual value of a population parameter is less than, greater than, or not equal to the value stated in the null hypothesis. So, the alternative hypothesis states that what we think is wrong about the null hypothesis. So, that is null and alternative hypothesis. So, we should note that they are non-overlapping hypotheses. If you will reject your null hypothesis, then you will accept this alternative hypothesis. So if you don't accept this alternative, then you should accept the null hypothesis. And we need this hypothesis testing or significance testing. So that is the difference between the null hypothesis and then alternative hypothesis. Null hypothesis expresses the idea of non-significance, and then for alternative hypothesis, it expresses the idea of significance. For example, in our previous example that I have mentioned, that there is no significance difference on the math performance of the education students and the engineering students. So that is your null hypothesis. So your alternative would be stated this way, that there is significant difference on the math performance on of the education students and the engineering students. So that's the difference between the null hypothesis and alternative hypothesis. So we cannot arrive with the statistical decisions without undergoing on the hypothesis testing or significance testing. And you should know what and you should know this null hypothesis and alternative hypothesis. So that's, again, that's the two kinds of hypothesis, the null hypothesis and then the alternative hypothesis. Next, reminders. The null hypothesis is generally a statement of equality or status quo, or will imply no change. In other words, there is no significant difference. There is no significant relationship. They're just equal. Whatever group you are, they're just equal. Let's say the performance of the boys and girls. Let's say in math performance. So if you have their null hypothesis, then they're just performing equally. So the hypotheses are statements about a parameter or distribution of the population. And then the null and alternative hypotheses are mutually exclusive. When I say mutually exclusive, meaning they are non-overlapping because you need to have a statistical decision. So if your data or sample data falls into this area, then you should have a distinct decision that it is fail to reject or reject HO. So that is a kind of hypothesis or the reminder about the hypothesis that the null and alternative hypothesis must be mutually exclusive. Okay, let's have some example. Is there a significant difference in the academic performance of students when grouped according to type of diet? Let's say type of diet, you're a vegetarian, and then the other group is non-vegetarian. So your null hypothesis will be stated this way. There is no, reminder, null hypothesis, it expresses the non-significance. So your null hypothesis statement would be like this. There is no significant difference in the academic performance of students when grouped according to type of diet. And then your alternative hypothesis, your HA or your H1, there is, again, alternative hypothesis expresses the idea of significance. So your statement would be like this. There is a significant difference in the academic performance of students when grouped according to type of diet. Again, another example. Is there a significant difference in the resiliency level of education and nursing students? So your statement for null hypothesis would be like this. There is no significant difference in the resiliency level of education and nursing students. And then your alternative hypothesis or your HA, there is a significant difference in the resiliency level of education and nursing students. So that's how you do your null and alternative hypothesis. Reminder, null hypothesis, it expresses non-significance. And then your alternative, it expresses the idea of significance. And then let's talk about some relationship. So a statement, is there a significant relationship between the grade, score, and academic performance of 70 Adventist students? When I say great, that is the courage and resolve, the strength of character, especially in the long term, or you can say perseverance. Okay, so if a person or if a student is greedy or a person of persevere person with a long patience, with his her perseverance is really great, will that be manifested in his academic performance? So that is your statement. So your null hypothesis would be stated this way. There is no significant relationship between the grade score and academic performance of its day students. And then your alternative hypothesis would be stated this way. There is a significant relationship between the grade score and academic performance of its day students. Again, that's a few examples of stating your null and alternative hypothesis. Okay, let's talk about the simple and composite hypothesis. In the previous slides, we've talked about the null and alternative hypothesis. Now, we'll talk about the simple and composite hypothesis. So, a parametric hypothesis which describes a distribution completely is called a simple hypothesis. Otherwise, it is called composite hypothesis. So, when you say simple reflects that where shows the parameter specified value wherein reflects. So if our hypothesis is simple, then it really has a specific value. So if it is composite, then it's just like greater than or less than uh, any value, but as long as it is less than or greater than. But if or not equal, but if it's simple hypothesis, it really specified a specific value. So that is the simple hypothesis. So, for example, in case of normal distribution with mu or population mean or the population variance or the sigma squared, where mu is equal to 5 and our variance or population standard deviation is equal to 3 is simple hypothesis, whereas mu is equal to 5 as a composite hypothesis as nothing have been said about variance or standard deviation. So similarly, mu or the mean is less than 5 and then your population standard deviation is equal to 3 is a composite hypothesis. So let your null hypothesis mu is equal to 5 with the null hypothesis, then here's how you should look at it in your alternative hypothesis. If your HA or if your alternative hypothesis is like this, mu is not equal to 5, then it is two-sided composite alternative hypothesis because as long as it is not specific, as long as it is not equal to 5, okay, that's how you do your critical region. And then if your HA will say or your alternative hypothesis is your mu is less than to 5, then it is one-sided left composite alternative hypothesis because it's just declare less than 5. It's not a specific value as long as it's less than 5. And then your mu is greater than 5 is one-sided right composite alternative hypothesis because it does not specify our specific value as long as it is greater than 5. So that is the difference between the simple and the composite hypothesis. When I say simple, it really has a specific value, whereas the composite does not really declare a specific value. So that's the difference between the simple and the composite hypothesis. Then let's talk about the two types of error. We have two types of error, the type 1 and the type 2 error. So type 1 error is the first type of error committed is when the null hypothesis or your HO is rejected wherein reality, wherein it is the true solution to the problem, then that is an error. So that is the first type of error. That null hypothesis is supposed to be true, but with your hypothesis testing, you declare it not true, then that is called a type 1 error. And then when I say a type 2 error, the second type of error committed is when the alternative hypothesis is rejected wherein it is the true solution to the problem. It's supposed to be true that there is significant difference, there is significant relationship, but then you did not accept that truth, then you committed a type 2 error. So that's the two types of error, the type 1 and the type 2 error. So let's discuss it further with this decision matrix. So if your action is reject HO and then in reality HO is really true, then you've committed a type 1 error because you rejected it when in fact it is true. And then if you rejected your alternative hypothesis when in fact or in reality HO is false, then you have a correct statistical decision. And then if your action failed to reject HO and then HO is true, then you have a correct decision. However, if you fail to reject HO but then HO is false, it's not true, then you committed a type 2 error. So that's the two types of error, the type 1 and the type 2 error. When I say type 1 error is you reject HO when HO is true. And then type 2 error is you fail to reject HO, but then in reality, each HO is false. So that's the two types of error. So, what is the probability of committing errors? The probability of a type 1 error is usually denoted by alpha. Okay, so in your hypothesis testing, you will always see this alpha. So, alpha is equal to the probability of type 1 error. So, that is the probability that you reject HO when HO is true. So, it is also known as the level of significance of a statistical test. That is why whenever you see a journals, they're stated in the alpha, or what is the level of your significance of your study. Then you state like 5% or 1%. That is the probability of committing a type 1 error in your statistical hypothesis. So that is the alpha, level of significance. So 5% as default or 1%. And then what is the probability of a type 2 error? We have the type 1 error and the type 2 error. So what is your probability of committing a type 2 error? So it is usually denoted by beta. So beta is equal to the probability of type 2 error. So it is equal to the probability that you accept HO or you fail or accept HO when HO is actually false in reality. So that is the probability of type 2 error, or with the denoted by beta. But usually in our hypothesis testing, we will just use most of the time the alpha, which is the level of significance, the 5% or the 1%. So, what is this level of significance or significance level? So, it refers to a criterion of judgment upon which a decision is made regarding the values stated in a null hypothesis. And then the criterion is based on the probability of obtaining a statistic measured in a sample if the values stated in the null hypothesis were true. So it is the probability level below which we reject the hypothesis is called level of significance. So in behavioral science, a criterion or level of significance is typically set at 5% or 5 or 1%. So unless stated, you will always use the default of level of significance throughout our study, throughout this course, as 5%. Again, by default, if not stated as 1%, then you will use 5% level of significance throughout our class. So that is the level of significance or significance level. And then the significance level is the criterion used for rejecting the null hypothesis. So the choice of level is largely subjective, and the most common choices for the level of significance are 0.05 or 5% and 0.01 or 1% level of significance. So setting alpha at 5% or 0.05 indicates that the researcher is 95% confident that the HA is true or accepted, and the researcher has 5% chance of rejecting the null hypothesis. You have only a 5% probability of committing a wrong conclusion, a wrong statistical decision. So we know that no one is perfect, and even in research, we should allocate that error as human. Or accept reducing the alpha or level of significance at 0.01 or 1% indicates that the researcher is 99% confident that he is making the right decision and 1% chance of committing errors, or it's more sensitive. Okay, so that's the level of significance. So, okay, in some computer-aided analysis, you will always see this, the p-value or the probability value. and is the level of marginal significance within a statistical hypothesis test representing the probability of the occurrence of the given event. So the value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. So for example, this is our distribution. So here you can see the 5%. So in conclusion, the probability value, if it is less than your alpha, or if it is less than your level of significance, then your decision must be to reject HO. And then if your p-value is greater than level of significance or your alpha, which is usually 5% or 1%, then you fail to reject HO. You have accepted it, that there is no significant difference. So that is the p-value. It is the level of marginal significance within a statistical hypothesis test representing the probability of the occurrence of a given event. And then what is this rejection region and acceptance region? So before you have your statistical decisions, your conclusions, you have your statistical testing or your hypothesis testing, you need to have this rejection region where what area that I can declare that my study or my outcome or my research or my experiment, I can declare that there is no significant difference or there is significant difference. What is my basis? What is my criteria? So you have in a distribution, you need to know your rejection region. And so the rejection region is the region in which the null hypothesis is rejected if the test statistics falls within it. So by setting the level of significance, the rejection or critical value can be determined. So it serves as the basis whether the hypothesis is rejected or not rejected. So for example, even in your grades, in what area that I can declare that I have passed. So for example, you can only declare that you've passed the subject if your grade is 85 above. So it's just like that. That's the rejection region. What is my basis whether my hypothesis will be rejected or not rejected? So in your statistical testing or your hypothesis testing, you should know this rejection region and acceptance region for you to have a statistical decision. So the location of the rejection region is determined by the nature. Again, we'll go back to the hypothesis. Well, the nature of the alternative hypothesis or your HA, whether the hypothesis is one-tailed or a two-tailed test. Okay, so to test is a rule through we test the null hypothesis against the given alternative hypothesis. So the test of significance is the procedure which enables us to decide on the basis of sample information whether to accept or reject the hypothesis or to determine whether observed sampling results differ significantly from expected results are called tests of significance, rules of decisions, or test of hypothesis. So in our example, a normal distribution, if you have your two-tailed test, then the 5% error must be distributed on both sides. Or if it is one-sided, then it's just 2 or 5% here. Then if your data falls into this area, then you will declare rejection region or non-rejection region. So you need to know where your data falls based on your hypothesis testing or based on your statistical analysis. So throughout our class for this course, we will use these steps in statistical hypothesis. So whatever test we use, whether it is one sample, two-tailed, or Kruskal-Wallis, or it is analysis of variance, we will use this throughout our class, these steps to statistical hypothesis. So step 1, you have to state your hypothesis. So that is the HO and then the HA, or your null hypothesis or your alternative hypothesis. And then we begin by stating the value of a population mean in a null hypothesis which we presume is true. So we can use any parameter depending on our problem. let's say. But commonly we use the mean or the mu or the population mean. And then step two, we should set the criteria for a decision or your alpha, whether it is 5% or 1% level of significance. And then to set the criteria for a decision, we state the level of significance for a test. For example, you just state alpha is equal to 5%. So that is for step two. And then for step three, you have to compute the test statistics, or this is your test statistics calculation. So use the appropriate test procedure and give the necessary analysis results. Sometimes we don't have to present all our manual calculation. We just have to present necessary analysis results. So this is our step three, computing our test statistics. And then for step four, that is our critical region. So that is the rejection or the acceptance region. And it is stated with the decision rule is stated in this place, okay, in this place or in this area. We use the value of the test statistics to decide on the null hypothesis. So the decision is based on the probability of obtaining a sample mean given that the value stated in the null hypothesis is true. So and then the step 5, this is your decision region or your decision. State your statistical decision based on the result of your critical region. Let's say, failed to reject HO or reject HO. So that is where you should state your statistical decision. And then on step 6, you have your conclusion and then your recommendation. So state your conclusion and recommendation based on the result. So we will use throughout our class these 6 basic steps of statistical hypothesis. So let's review some of parametric tests. We have the Z-test in our elementary statistics, whether in your high school or in your elementary statistics. So what is this Z-test? I believe you have an idea already about it. Then Z-test, the T-test, and person R correlation. So this is one sample test, the two population test, and then for correlation. Okay, so Z-test. Z-test is when a population is normal. The distribution of its sample means regardless of its size is also normal. So on the other hand, if the population is skewed, the sampling distribution of the sample mean is approximately normal when sample sizes are sufficiently large. For both of these cases, if the population is normal or at least approximately normal with sufficiently large sizes, testing the hypothesis should be best performed through the Z-test. Under this test, the population variance should be known to the researcher. So in your textbook, you can see there in your hypothesis testing there is a Z table, Z tabular table where you can find for your for your rejection region, your critical region. So if it will be lower than this value, then I will declare significance, or if it's higher than that, significance. So depending on your distribution or your value, this is the C table or areas under the normal distribution. This is where you base your decision if you use the Z-test. Okay, for example, so these are the critical values of Z at varying level of significance alpha. So if you have your two-tailed, then it is 5% error or 5% level of significance, then this is your default, this is your decision rule. So you can only reject HO if Z computed, that is where from your that is calculated from your data, is greater than or less than to 1.96. Where this 1.96 came from, it's from the Z table corresponding to your areas. Okay, so that's an example of your critical region 1.96 if it is two-tailed. And then if it is one-tailed, then you should use this reject HO if Z computed is greater than or less than 1.645. Okay, so that's an example of using the Z table. And then another review is the t-test. So if you have one sample test, then you use the z-test. If you are comparing two groups, let's say the performance of boys and girls, the performance of education students and engineering students, then we will use the t-test. Okay, so it is the statistical tool, statistical testing for two population groups or two groups. So a t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or treatment has an effect on the population of interest or whether two groups are different from one another. And then a t-test can only be used when comparing the means of two groups. If you want to compare more than two groups, then we can use another statistical tools. But usually it is analysis of variance in parametric tests. So let's have some example. A statistics course is taught to 15 students by a traditional procedure. So that's another group. Students have undergone this traditional procedure. And then a second group of 12 students was given the same subject taught of technological aided methods. So, and then at the end of the term, similar tests were given to each group. So, it is 15 students, they are taught with traditional procedures, and then another students, they are 12, they are taught with technological aided methods. So, after that, they have this test. They take a test or an exam, and then we will compare if there's significant difference on these two groups, the traditional procedures and then the technological aided methods students under this category. Then the first group made an average of 83 with a standard deviation of 5, while the second group made an average of 85 with a standard deviation of 4. And then we test the hypothesis that the two methods have no significant difference using a 0.05 level of significance. So what we will use? So we will use the t-test because we are comparing two groups. Okay, so here's an example of how we state our alternative and null hypothesis. So statistical presentation, you will have you will present your null hypothesis this way. The mu1 is equal to mu2 because we have the two groups, or mu1 minus mu2 is equal to 0 because they are just equal, assuming that they are equal. And then the two methods, or in a statement form, we will state our null hypothesis this way. The two methods have no significant difference. Remember, null hypothesis expresses the non-significance idea. And so, or we can state it this way. There is no significant difference on the two methods. Okay, and then your alternative hypothesis will be stated this way in statistical form. Mu1 is not equal to mu2 because they're different, or mu1 minus mu2 is not equal to 0. Our state in textual presentation, we can state our alternative hypothesis this way. The two methods have significant difference, or there is significant difference on the performance of students when grouped by technological aided methods or traditional one. So, and then our step 2, that is putting our level of significance, or alpha, is equal to 0.05 or 5%. And then doing the calculation using the formula for t-test, you can arrive to the value of t approximately negative 1.126. So that is our computed t value. Again, that is our computed t value based on our sample, based on our data. And now we will present our critical region. So this is again default. This is our decision rule. Okay, this is where we base our statistical decision. So you should know the decision rule. So reject HO if T, absolute value of our T computed, that is where we computed for our data, is greater than T alpha divide 2 because it is two-tailed, 25. It is actually called as T tabulated. T table. This is the value from the t distribution, where this is fixed, where t computed is equal to 1.126 based on our calculation, and t 0.025 because it is divided into 2, it's because it is two-tailed, and then 25, that is our degrees of freedom. Degrees of freedom is our total number of samples minus 2. So in two groups, in one group we have 15 students, and then the second group we have the 12, then 27 if we add them, and then minus 2, that is 25. Then it is from the table. Later I will show you how to find this critical value. So 2.0060. So then since 1.126, this is a value from our t computed, is not greater than to 2.060. Hence, because this is our decision rule, we can only reject HO if it is greater, but that is not true. So, hence, we fail to reject HO. So, step 5, fail to reject HO. That is our conclusion. And then for our, for our decision. And then for our conclusion and interpretation can be stated this way, or you can have another thought. The two methods have no significant difference. It is based on our hypothesis. This implies, so this is our interpretation based on the readings or based on observations. This implies that whether you use the traditional procedures or technology-aided methods, student performance is not statistically significant different. So that is how you should do your conclusion and interpretation. So this is an example that we will be using for the rest of our class. So this is how you find your T tabular, or the critical value from your distribution. T is a T distribution. So alpha, we have a level of significance of 0.05, but since it is two-tailed, so we divide it by 2, 0.025, and then our degrees of freedom, n minus 2, our sample minus 2. So we have two groups, 15 from one group, 15 students in one group, and then 12 students in second group. Then total is 27. So when we compute degrees of freedom, 27 minus 2 is equal to 25. So how do we find the critical value? In a table presented in your textbook as well, then you find it there, the F, degrees of freedom, that is 25. And then our area, our level of significance, it's two-tailed, 0.025. Then our critical value is 2.060. So that's how you find the critical value in the T distribution. So that is an example of our T. And then another example is the person-R correlation, or the test of relationship, test of association. So another example, the age and systolic pressure readings of 15 individuals were recorded as follows. So my age is, for example, but I'm not 32. My age is, for example, the person 1 age 32, then the SBP is 115. Then the second person is 35 age, and then 1, 2, 3, the SBP. So on and so forth until the 15th person. So now we will compute the person R and interpret its value. So is there a significant relationship between the age and systolic blood pressure reading? So we will use by default the alpha level of significance of 5%. So, doing the minor calculation with the person R correlation, we arrive with this value. The R is approximately equal to 0.88. So, for descriptive interpretation, so the value of 0.88 is in the category of positively strong and high correlation. So, the age and then the SBP are strongly correlated from each other. So, we can have this conclusion. This shows that age and SBP has a positively strong relationship to each other. Further, the increase on age is likely to have an increase in SBP, and consequently, the decrease in age is likely to have a low SBP. So, but we don't know if it is statistically significant or not. So what we will do, we will have this hypothesis testing on R. So, rho, this is for relationship, is equal to 0. There is no significant relationship between age and SBP. That's how you state your null hypothesis. And then your alternative hypothesis, rho is equal to 0. is not equal to 0 rather. So there is significant relationship between H and SBP. So our level of significance is 0.05 or alpha is equal to 5%. And then our test statistics that is T computed is equal to R, that is our correlation value multiplied to the square root of n minus 2 over 1 minus R squared. So by calculation, doing the calculation, we arrive with the value of T computed is approximately equal to 6.63. So now we have our critical region. So this is our decision rule. Reject HO if T computed is greater than T 0.05, that is our alpha, divide 2 and 13 because our samples, our respondents are 15. So minus 2 is equals 13. And then by calculation, our T computed is 6.63. And then our T tab is equal to 2.160. And so since T computed is greater than T tabulated, hence reject HO. So reject, our decision is to reject HO. Then let's go back to our hypothesis. What is our HO? Then we have to reject it. So in other words, we accept the alternative hypothesis and to say that there is significant relationship between H and SBP. So that is a few examples of parametric test using the 6 steps of hypothesis testing. So as reminder, dear students, if you have your Bibles, you may open it in 1 Thessalonians 5, verse 21. It says, "But examine everything carefully. Hold fast to that which is good." If our research and our testing, we need to have this hypothesis testing and examine if we really have a good or correct statistical decision. So in life, as in our journey to heaven, in our spiritual growth, in our spiritual maturity, examine everything carefully. If it is really significant in your life or if it's not. Then if it's not significant, then leave it, then give it up. And if it's from worldly things, so again, dear students, examine everything carefully if it is significant or if not. Again, thank you so much. May God bless you and see you in our next discussion. God bless and have a nice day.